Hi everyone. Today's lesson is a reminder of how to use the distributive property. And we're going to do this in a couple of different examples, one using food and then the next using our mathematical terms and numbers. Looking at these examples, we're first going to start with these pictures of fruit up here. So I drew a quick little recipe for some fruit salad. As you can see, we have 1 apple in our recipe. There are 10 blueberries and 2 cherries to make this recipe of fruit salad. And then in real life, a lot of times what happens is when we're making a recipe, especially for a larger group, we have to multiply the recipe by a certain number to make sure that we have enough food. And so one thing that we have to remember when we're doing this with recipes is that we have to multiply each ingredient by the same number to make sure that the recipe is going to taste the same. So for example, if we put a bunch more apples in, but we don't increase the amount of blueberries and cherries in the same way, our fruit salad is not going to taste the way that we expect. And so this is one way to kind of see the distributive property in action in real life. So what I'm going to do is I'm going to put some mathematical symbols in here. I'm going to put 2 plus signs because in our recipe we're going to put all of this fruit together. And the next thing I'm going to do before I begin is to put some parentheses. That just keeps all of the ingredients for my recipe together. Now to do the distributive property to this, I need to figure out how many times I need to make this recipe. And so I'm just going to quadruple this recipe. That means I'm going to need 4 times as many ingredients. Now, there's 1 apple, and so I'm going to make sure that I'm going to do 4 times 1 apple, which means I'm going to have 4 apples, and I'll show this mathematically in a second. The next thing I'm going to remember is I need to also quadruple the rest of my ingredients, so I'm going to need 4 times 10 blueberries, which is telling me I'm going to need 40 blueberries. And the last thing is I'm going to need 4 times 2 cherries, which means I'm going to need a total of 8 cherries for my recipe to taste the way I'm expecting it to. And so this is just kind of a way to see the distributive property happening in real life. Below this, I'm going to show you what this would look like in math. So I'm going to assign some variables to these fruits. And so for example, here I have 1 apple, so I'm going to call that letter A. A for apple. I could put a 1 in front of it, but usually when the coefficient is a 1, we keep it with just the variable A. The next thing I'm going to do is I'm going to add 10 B for blueberries. So 10 times B shows me that there are 10 blueberries. And lastly, I'm going to add 2 cherries, so I'm going to put 2C for cherries. I'm going to keep my parentheses to keep my recipe together. So distributive property, my brain likes to see it. And one way that I can do that is to use these arrows to make sure I quadruple the first ingredient, the second ingredient, and this third ingredient over here. And then if I follow each of these arrows, I'm going to get a simplified expression. So 4 times apples means I'm going to need a total of 4 apples. So I got 4A over here. The next we had 10 blueberries, but we did 4 times 10 blueberries. So that was adding 40 blueberries, so 40B. And then we're going to add our last ingredient, 4 times 2 cherries, or 4 times 2C, got me 8C. And that is my simplified expression. I can't simplify it anymore because we're not yet going to combine apples, blueberries, and cherries. So in math, you can only add things when they are like terms or having the same variable. And since this has an A, this has a B, and this has a C, I can't combine them anymore. Okay, so let's do this on 2 more problems. We're going to have 5 times the first term, which is X. And we're also going to remind ourselves to do 5 times the second term, which is 3y. So I'm going to do 5 times x. I know that that's 5 times x because they were multiplied. I can just stick them together. We're going to bring down my sign, which is plus, and then we have 5 times 3y. I can do 5 times 3, which is 15. And we're also going to have times y, but I can't go any further because I don't know what those variables are. They're unlike terms, so I can't combine them. Okay, and last but not least, we're going to do this one. I'm going to do 3 times 2q. I'm going to do 3 times 3, and I'm going to do 3 times t. That had 3 different terms inside the parentheses. Okay, 3 times 2 is 6q. So I'm going to write 6 times q. I'm going to borrow this symbol, which is a subtraction. 3 times 3, I know that answer is 9. I'm going to take the next symbol, which is plus, and 3 times t is 3. t. So my final answer is 6q minus 9 plus 3t. Now I want to give you a moment and pause the video if you need to. You can either copy these problems down on a scrap piece of paper, or you can pause the video and go to the document that I shared with you and print this off so that you're ready to practice together. So let's use distributive property on these 4 practice problems. And if you remember, my tip is to use arrows to make sure that you can distribute the number on the outside to each of the terms on the inside. So this one, I'm going to do 4 times 5 first, which is 20. And then I'm going to add 4 times 6, which is 24. And what you'll notice on this one is I actually have a final step because these are like terms. These are both constants. Neither one of them has a variable. So I'm actually going to be able to add these together. So I'm going to add 20 and 24, and my final answer in this case is going to be 44. I was able to do that because these were both like terms. Okay, let's do the next one. 6 times x is going to be my first part, and 6 times 4 will be my next part. 6 times x is 6 stuck to an x. I'm going to borrow my sign, which is a minus, and 6 times 4 is 24. This is my final answer because these are not like terms. Since we have a variable x here, but there's no variable x here, we can't combine them any further. Next, we have 7 times x and 7 times 8. 7 times x is 7x. The sign that I'm going to use is a plus, and 7 times 8 is 56. I'm also done on this one because they are not like terms either. And last but not least, we're going to do 2 times x and 2 times 3. 2 times x is 2x, minus is my symbol, and 2 times 3 is 6. I'm done. Since I have unlike terms, I can't combine them any further. So there you have the distributive property. Hopefully this was helpful to remind you how to solve these problems. And now it's time to go practice on your own.